This video is meant for a flipped classroom on completing the square. So we're going to start off by learning how to complete the square, what that means, and then we're going to work on solving quadratic functions by completing the square. So first thing we want to do is talk about all the ways that we already know how to solve a quadratic function. Okay, we know how to solve by graphing, and we know that that's when we have our x-intercepts. So you could graph a function and look for its x-intercepts. There's the quadratic formula, which is that x equals negative b plus or minus the square root, blah, 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 blah. And then there's solving by factoring, which is when you get your equation to look like this. And then lastly was undoing, which we learned at the very beginning of the year, or very beginning of the unit. And that was the one that I think is probably everyone's favorite right now. It was those problems we had when there was no b term. And we were able to just kind of draw the balance line and solve. And we got nice, pretty answers. All right, so completing the square is going to let us solve quadratic functions by undoing, even if we have a b term. So we're going to kind of come full circle and go back to the beginning of our unit. We're going to learn how to complete the square so we can solve by undoing, because I think we would agree that that's probably even easier than solving by factoring. So completing the square. Mathematicians are not creative people, okay? So they are going to use the phrase completing the square because that's exactly what they're going to do. We're going to complete this square. Right now it's not complete. We're going to complete it. Okay, so we're going to use this area model to help us. So we're going to split x squared into x and x because that's going to make x squared. And because this is a square and it's not a rectangle, we have to split the b term equally between here and here. So half of 6 is 3, so that means we need to put 3 here and 3 here. So that would give us 3x in this box and 3x in this box, which gives us indeed that 6x. So to complete the square, we're really trying to find what is this piece right here that completes it, that finishes it, and that would be 9. So to complete this square, the question mark would be 9. And the nice thing about this is we have both sides the same exact thing. So we could say that this is x plus 3 times x plus 3, or even better, it would be x plus 3 squared. So let's complete another square. Okay, so we're trying to find this value of the question mark that would complete this square. So I'm going to have x and x, which will make that x squared. And then I have to split this 22x evenly because it's a square, so it has to be even on both sides. So if I split 22 in half, that would be 11 and 11. So that means this would be 11x and this would be 11x, which again, across this diagonal will give us that 22x. And to complete the square, 11 times 11 is 121. So the question mark would have to be 121 to complete the square, which would then let us say that in factored form, we would have x plus 11 times x plus 11, or even better, x plus 11 squared. So you try this one. Go ahead and pause the video and try and complete this square. So you would have x here and x here, which would give you x squared. And then you have to split the 13 evenly. So that'll give you a decimal, but we're not scared. So you would have 6.5 here and 6.5 here. So that gives you 6.5x and 6.5x. And then in this box right here, you would have 42.25. So that would mean this value right here is 42.5, or excuse me, 2.5. There we go. So when you want to write this in factored form, you would have x plus 6.5 squared. So you might be asking yourself, well, why does this make it easy to solve? Okay, so let's look at how we would use completing the square. Now that we know how to complete the square, let's figure out how we could use it to make it easier to solve. So the first thing we're going to do is we're almost going to ignore this equals 0 right now. Okay, I just want to look at this part right here and actually complete the square. So like the other problems, we would have x and x. And we're going to split the 10x in half because it's a square, so it's got to be the same thing on both sides. So I have 5x and 5x, and this has to be 25. So in order to complete the square here, I need x squared plus 10x plus 25, and that's equal to 0. But if I add 25 to this left-hand side, to keep this balanced, I'm going to have to add 25 to this side. I can't add 25 on the left to complete the square without adding 25 on the right to keep it balanced. So then I have, if I factor this out, this gives me the perfect square of x plus 5 times x plus 5, which is just x plus 5 squared. And 0 plus 25 is 25. Well, now this is really easy to solve. This is solving by undoing. You square root both sides. You have x plus 5 is going to equal a positive 20, and x plus 5 is going to equal a negative 20, and then you just subtract 5 from both sides. So you get the solutions 15 comma 0 and negative 25 comma 0. Okay, so hopefully that makes a little bit of sense. The idea is we want to solve by undoing. All right, if we look at another one, we're going to solve this one by completing the square. The problem is we have this value right here, this minus 22. And we didn't have that on the last problem. So we need to get rid of this guy so that we can complete the square. He's just in our way. We need to get rid of him. So to get rid of him, we're going to add 22 to both sides. Get him on the other side. We don't want to look at him. We don't want anything to do with him. So we're going to have p squared plus 16p is equal to 22. And we're just going to ignore this 22 for now. So we're going to complete the square. Let's see, 16 divided by 2 would be 8. So this would be 8p, and this would be 8 for 8p. So to complete the square, this box here has to be 64. So that means to complete the square, I have to add 64. But if I add 64 to the left-hand side, I have to add 64 to the right-hand side. So that gives me, when I factor this, put this in factored form, I'd have p plus 8 squared, because p plus 8 and p plus 8 is equal to 22 plus 64, which is 86. And then you just solve from here. So you're going to draw your balance line, square root both sides. You have p plus 8 is going to equal, we're going to go ahead and round 9.27. So I should put my approximate signs there. And negative 9.27. And then subtract 8 from both sides. So I'm going to have p is approximately 1.27. And p is approximately negative 17.27. And then you can write those as coordinate points. So your solutions are 1.270 and negative 17.270. So I want you to pause the video. Whoops. And try this one. And then when you're finished, you may check it. So, first thing we need to do is get this 20 on the other side. So I'm going to subtract 20 from both sides from the beginning. I'm going to have x squared plus 12x is equal to negative 20. I leave this big space here because I'm going to write the value that's going to complete the square here. So I'm going to have x and x, so that's x squared. And this will be 6. And this will be 6, so I have 6x and 6x. So I'm going to have to add 36 to complete the square. And if I add 36 to the left, I got to add 36 to the right to keep things balanced. So this becomes x plus 6 squared is equal to 16. Square root both sides. You have x plus 6 is going to equal 4, and x plus 6 is equal to negative 4. So if you solve these, let's see, you'd get negative 2, 0, and negative 10, 0. If you have any questions on any of this material, please see Mrs. Fike before school. Otherwise, we will have a task in class that will allow you to practice this more tomorrow.